Welcome to another episode of Sound Talk Show. We are going to code Wolfram Language Advent of Code 2025, Day 2, Problem 1. Let's see. So if you are here, say hi. If you are watching this offline, play at 1.5 speed. Okay. So what is this analytics? Okay, so let's begin. So Wolfram Language Advent of Code, Day 2, 2025. Okay, so can you see my screen? Check today's talk show. Check video, check audio, check. Okay, so Advent of Code. Okay, Day 2 gift shop. So we're gonna do this slowly and have fun. Play at 1.5 speed. If you are here, say hi. Love to see your comments. Showing browser. Okay. So can you see it? This stupid. Okay, you get this inside. You get inside and take the elevator to its only other stop, the gift shop. Thank you for visiting the North Pole. Gleefully exclaims a nearby sign. You aren't sure who is even allowed to visit the North Pole, but you know you can access the lobby through here. And from there, you can access the rest of the North Pole base. As you make your way through the surprisingly extensive selection, one of the clerks recognizes you and asks you for help. As it turns out, one of the younger elves was playing on a gift shop computer and managed to add a whole bunch of invalid product IDs to their gift shop database. Surely, it would be no trouble for you to identify the invalid product ID for them, right? They've even checked most of the product ID ranges already. They only have a few product ID ranges, your puzzle input, that you'll need to check. For example, this is one single line, several bunch of numbers separated by comma. The numbers, each number is like two numbers separated by dash. Okay, so this is your input. The ID range, so each item is a range, two numbers. Okay, so the ID range are wrapped here for legibility. In your input, they appear on a single long line. Okay, stupid Advent of Code, hard formatted page. They appear on a single long line, so you get one single long line. Okay, so you need to split string, something like that. The ranges are separated by commas. Each range gives its first ID and last ID separated by a dash, of course. Technically, that symbol is called hyphen, not dash, okay? The Zoomer generation, idiots. But the guy who wrote Advent of Code is not a Zoomer. So since I think he is like Malengen, since the young elf was just doing silly patterns, you can find the invalid IDs by looking for any ID which is made only of some sequences of digits repeated twice. Looking for any ID which is made only of some sequence of digits repeated twice. So 55, 5 twice, 6464, that's 64 twice, and 123, 123 would all be invalid ID. So some of these numbers, they have basically sequence of digits repeated twice. None of the numbers have leading zeros, so 0101 isn't an ID at all, okay? 101 is a valid ID that you would ignore, okay, because it's valid, okay. Your job is to find all of the invalid IDs that appear in the given ranges. Okay. In above example, so 11 to 12 has two invalid IDs, 11 and 12. Okay. So basically a sequence of numbers. So starting from a minimum to maximum, I presume, it's not a given. It doesn't say so, but let's presume, from minimum to a maximum. So among these numbers, including the minimum and maximum, you want to find all numbers such that they are basically a sequence of digits repeated once. Okay, so first thing you notice is that if the number of digits is odd, then that doesn't count, because it is impossible for odd number of digits to be the result of something repeated twice, because when you repeat once, the digits gonna be an odd number, the total number of digits. Okay, so 11 and 12 has two invalid digits. 11 and 12 both have even number of digits. Okay, then before we understand, we probably already understand the problem, but let's go further. So if the total number of digits are even, you exclude it. Wait, if it's odd, you exclude it. So you only consider numbers whose total number of digits are even. Then for those, if they, basically you split the number into two, then in fact this problem is probably easier if you deal with the numbers as string. So you basically match string. So in fact, if you do that, this can be done as a regular expression. Can it be done as a regular expression? Yes, I think so. If you do it as a regular expression, it basically automatically solves the problem. Yeah, you don't even have to filter even odd total number of digits, I think. Comments, okay? So 11, 12, then 95 to 115 has one invalid digit, 99, okay? 988 to 1012 has one invalid digit, 1010. Okay, then this big number range has one invalid ID, 1185, 1185. Okay, then this range has one invalid ID, 22222. Okay, then this contains no invalid ID. Okay, so this range, no invalid ID. Sometimes if you use the drawing pen as a mouse, it's not as good. Okay, so then this has invalid ID 446, and this range has invalid ID 3859, 3859. The rest of the ranges contain no invalid IDs. Okay, so it says 1, 2, 3, 4, 5, 6, 7, 8. So it's saying 8 of them has invalid ID, but how many total are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so 8 of the ranges has invalid ID. Okay, so adding up all the invalid IDs in this example produces that. Okay, so what do you get if you add up all invalid ID? Okay, let's get my parser input. Select all, copy, go back, close it, go to Emacs. So open a new save. So this is advent of code. let's just say xxx for now, okay? And let's get the proper name. So copy that. So search for xxx. Let's rename it. This will be Advent of Code 2025 day 2. Okay, copy. I mean, make it so. Okay, open this. That's a personal input. Close. And today's talk show. Start coding here. Personal input. Make a link. Make a list. Then move the file into the I directory. Okay, open it. Fantastic. Okay, so close it. So show in browser. So we got that personal input. Now the default input, let's copy it. Copy, and let's begin to code. Wolfram language, paste it. Okay, so here is the input. Let's start Wolfram language. Now, if you don't know, watch my previous videos. There's hundreds of them. Wolfram language for programmers, complete tutorial from the ground up, and where to download Wolfram language for free. It began free about 5 years ago. Then start Wolfram mode. This is for coding Wolfram language in Emacs. Okay, you can get it on GitHub. It's free. Thanks to Wolfram Research. Okay, now Wolfram language 3, Shift Enter to start the kernel and magnify. So we got, this is our work sheet. Okay, and and I'm using Sapphire keys in Emacs, the most efficient key binding system in the universe, more efficient than Vim or NeoVim, but for Emacs. Okay, so there's like hundreds of videos I talked about these topics. So anyway, so Wolfram language begin. Okay, so here is input. So let's just say input equals to. Now, normally it's a string, right? Separated by comma. So space without space. So let's just make it so. Okay. Now let's double check. Is our input without any space? That's correct. Okay. So now, so that's input. So first of all, string split. By default, it so let's say x input split by comma. Okay, then split it input. Okay, so we can do this, select all, paste in Wolfram language, so you can see, evaluate. So now you got a list of strings. Now for each one of them, you split again. So, so let's see, 11 and 12. So let's pick one. Let's say this example. Okay, for each range, they only have one invalid number, except the 11 to 12. Okay, so but okay, so anyway, so now let's try this example. So let's just try to work on this example. So you got a range of numbers. Okay, so if you want to use regular expression, so first of all, let's test regular expression. Okay, so for example, this number, let's say xx equals to this number. test regex. Okay, so that's a regular expression. String match. Okay, so here is the documentation for string split, and here is the documentation for string match pattern. So let's say XX. In this example, let's just say directly that number. Okay, then pattern. There are two ways to specify a pattern. One is regular expression, the other one is string expression. So let's just use regular expression. But meanwhile, let me show you what I'm talking about. So you go to today's talk show, Wolfram Language for Programmers, search for it, you'll find it on xali.info, http xali.info. Okay, so here you can string and regular expression. Okay, so you go to string, introduction to Wolfram Language string, then you got string functions, a list of all string functions, about 100 of them. Then you can get substring by pattern, delete substring, and so on. And the one section is regular expression and string expression. Regular expression you are probably familiar with. It's a string pattern. Now, but in Wolfram language, you also have string expression, which is basically like regular expression, but alternative syntax. Basically, just alternative syntax of regular expression. In fact, it's easier to read, but less familiar to most people because most people use regular expression in every other language. For now, let's use regular expression. So string match your regular expression. What do you want to match? Okay, so in regular expression, if you want to match a number, that's \d. Now \d plus. Okay, so wait, \d plus means one or more. Now, to be sure, let me check regular expression, Wolfram language regular expression syntax. Okay, so here is Wolfram language regular expression. Do I have the syntax example here? Regular expression syntax. Am I going? Say hi, okay? Put in a comment. String expression, regular expression. Wait, string replace. So let's go to the reference. Wait, why don't I say example of regular expression, ignore case, replace string by captured patterns. Okay, now I don't have a page of regular expression syntax, so we need to go to Wolfram language regular expression syntax. So here is a summary of syntax. So \d for digit 0 to 9, right? So you need to \, because \ is an escape character. So if you want \d in string, then that's gonna be \. So this is not very good. This is like in Emacs, Lisp, and also in Common Lisp, in Scheme Lisp, you only have one string syntax. So every time you have a \, you need to double it. Very bad. So anyway, regular expression d. Then you want to say this is repeated once. Okay, so let me show you. Okay, so basically you want the paren. Paren is for capture, and you want you don't you want grouping, you don't want actual capture. So let's see, question M. So we want to capture, okay? We want group, but we don't want capture. Treat uppercase, lowercase, okay? That's a case. That's these are normally flags, regular expression flags. Okay, so we want to capture, but without actual capturing. Repeated between m and n times. Okay, so okay, so I think it's just that. Then one or more, then repeated twice. Okay, let's double check. M and repeated between m and n times, and then you wanna say, then you want to put a anchor. That means this must be beginning of match. Wait, not that. Okay, and over here it's end of match. Now, do you need escape for the braces? This escape is usually very annoying. No, you don't. Okay, unless you want literal braces. Okay, comments. Guys, comments. Do we have like anyone watching? 4 people, okay? Just say hi. So am I going? Yeah. Okay, so that's a regular expression. We can run it. Let's see if it works, okay? Run, see what's the result. True, fantastic. Now we just try a few. Let's say 223 AA3. Run it. True. Now let's try something false. AA30. True. So we got fucked. Okay, so this is tricky. We don't want that. Okay, so this is also true. So that is incorrect. So you want this to be repeated twice. So can this be done with regular expression? I'm pretty sure. Hello, aspiring Windows compositor. Hello, functional programmer. I think you are. Combinatorics guy, something. So anyway, so back to this. So why is this true? So this means a digit, one or more, and string match. Now, string match, does it needs to match the entire pattern or not? I think so. Let's try, okay. This should return false because that's not the whole pattern. That's right. So in that way, we don't even need the beginning and end, okay? Try it. It returned true, but it shouldn't. Why is that? AA3, AA30. String match, digit one or more. Okay. Insta problem. Why is this true? We don't know. Should be fine. Let's go back to the regular expression thing. PMN. P repeated between M and N times. So we say exactly should be 2 times. So there's no way that returns 2, so the shortest consistent string that match. We don't want the shortest, okay? It's a question mark, right? And string matching the sequence P1, P2, okay? So the following represent classes of characters. That's right, digit. Okay. Then the following named classes, you can use named classes. Okay. The following represent positions in string, beginning and end. Okay. So backslash is literal characters. So backslash gn is the captured pattern, represent the captured pattern. Okay, and if you want to actually replace, you use $n. Okay, so we got that, but now we have this bug, StringMatchQ. We have this bug that's not we don't know why this returns true, because we say two. What? Problem. So let's try this one. Paste. Let's try this one. Paste. Shift enter. Why is it true? I know, understand. Let's just try some fancy ones. Copy. Paste. Let's say 3. It must repeat it 3 times. It's even true. Now if you remove the paren, what happens? Okay, nothing to repeat in regular expression. Okay, this 3 I don't understand. Why is it returned true? You know? Why is this returning true? Let's think about again. So digit. So if you do that, that's a digit true, of course. Now if you remove the paren, that's true, of course. Now, are you sure that's a digit? What the fuck is going on? /d, unknown string escape /d, that's right. So if you have double D, then it's a digit. Now if you put a number, that will not match because string match needs to match the entire thing. It will be false. Let's try it. That's right, false. But if you put dot anything, then dot anything, then a digit somewhere, it'll return true. That's right. So we make sure this digit, this D is a digit. But this repeat got a problem. So why can't we, let's say TTXX, okay? And let's say this pattern, let's make it simple. Let's say TXTX, okay? TX repeated twice, true. Now if you say 1 1, would it still return true? False. Okay, so here is TX repeated 2 times, true. Now TX but repeated once, false. So this repetition seems to also work. I mean the repetition syntax. So if you say 3, it'll return false. That's correct. Unless we actually add another TX there. Now it'll be true. Okay? Now, but then why is that this digit shit get us into problem? I wonder. Why is this 83 AA3 AA3? Then we got a 0. Right? What? So if you just say 1 2 3, would it return true still? So we got something wrong, something seriously wrong. I don't understand. So this digit, 1 or more, must repeat at least twice, minimum and maximum. Digit, 1 or more. So plus means at least one or more, repeated at least twice, and no more than 2 times, exactly repeated 2 times. And the input is 1 2 3, but it returns true. Like what the fuck is going on? Okay, there's something I don't understand. There is something I don't get completely. Why is that every time we code there is some problems? Now this can't be, because in Python we can try Python. Let's put it back, okay? For example, in JavaScript, okay, Python, paste. Python, how do you match regular expression? I forgot. Let's go to Python tutorial. Search for it. Xali, my name, Xahle, Python tutorial. You'll find it. String, Unicode. Then there's a regular expression somewhere. String, Unicode, string, module, miscellaneous regular expression, check if string match, research pattern, string flags. Okay, so let's try Python. Copy, paste. So Python, the text is gonna be 1, 2, 3, and the pattern we want to search is basically is this. Okay, so got Python raw something. Okay, so let me. So raw means there's no special treatment of backslash. So that in this case you just need one backslash. Now do. So digit plus then text. So text, let's remove it. Let's just make it simple. Okay. Run it. Yes. So in Python, this also matched. Okay, something fundamental that I'm getting wrong. Wait, why is that something fundamental? Something fundamental about regular expression I'm getting wrong. And this just print, okay. It matched span 03. Wait, what? Something fundamental about regular expression syntax that I'm not getting correctly. Let's see, regular expression syntax. I wrote a tutorial. This is like 15 years ago or almost 20 years ago, because I have a fight with the Python people. Like, anyway, that's a long story. You can read about it somewhere in the article. Okay, so but we want to know why is even in Python this returns true. Let's make it the other way. It's easier to understand. Okay, yeah, this. So it returns yes, so it matched. So a digit, one or more, and repeated. Oh, I see. You see, I got it. You see, this digit you captured. This is digit one or more. So there's more tricky. Okay, so it doesn't needs not to be exact the same digit. But still, in this case, I don't understand why it's true, because there's odd number of items here. In the case of Python, you need to put that. If you put beginning of the string and end of the string, then it returns false. Oh, it's still true. Okay, there's something I don't understand, but anyway, I got part of it, because this means it this is not very specific digit, sequence of digit. It could be any. So 1 is a sequence of digit, 2, 1 or more, and 2 is a sequence of digit, 1 or more. So therefore, 1, 2 is considered a repetition. But in this case, I don't know why if you say 3, in this case, why is 3 matching? I don't know. So anyway, so there are now 2 issues. One is that figure out why is these 3 matching. The other issue is go back to our problem and make that digit a specific reference. Okay, so can this actually be done with regular expression? I'm not sure. But why is this? Okay, so now let's go back to Python. So Python regex functions. We want the one. We want one that let's try this. Yes. Okay, it returns yes. Okay, so there's something really tricky about slash the digit 1 or more. I don't understand why is this returning yes. Okay, that's a question. So let's not use that. Let's use this. Yes, also yes. Okay, so what about that regular expression functions? Yeah. Regex functions, then regex syntax. \d is digits, that's right. And we want to know about the repetition qualifiers. Okay, then you got these exactly m copies of previous regex. Okay, now let's just try one single value. Not 2, 2, just 2. Run it. It returns yes. I don't understand. Why is it yes? Because we have this boundary. We have this boundary. Okay, so that has to do with the regex function. Okay, so this is about either the pattern should match the entire string or it can be just part of the string. So let's look at regex functions. So match start at the beginning of string, but so if you use match and you use the $sign to signify the end, why is it not? So $sign, so you need to $sign matches the end of the string or just before the new line. Okay, so if the multi-line flag is given, then it also matches before any new line. No, I don't want the multi-line flag. Oh God. Question. Okay, so let's ignore the Python for now. Let's go back to Wolfram language. Okay. Now we know this. Let's try. Can we do like that? True. Okay. So you can just have a single number. You see, false. Okay. Now let's go back to Wolfram language. Wolfram language regular expression, you see it says here repeated between m and n times, but it did not give a single number specification here. Tech notes, regular expression, special characters. Let's see tech notes. Yeah, tech notes is like too elaborate. You see, there's no single m example given, which is kind of this doesn't seem good because it seems to also support this single number. So tech nodes, string expression. Okay, so let's look at my tutorial. Yeah. God. Okay, so God, why is there's always this little problem? Is it true it supports that? Yes, because if you say that it return false, yes, so this single braces number syntax works. However, it's not well documented here. Is that right? So is this a valid point? Did I find a valid bug in the Wolfram language documentation? I mean, is that, did we spend all this time? Is that true? We found a valid criticism or incompleteness or imperfection of a problem in Wolfram language documentation, because we want to know this repetition syntax, but with one single number there, but it's not mentioned here. However, we tested, it seems to work. You see these two. So I think there's a valid criticism of the Wolfram language documentation. It's not mentioned. Scope, basic constructions. Let's see. Basic constructions. So there's a repetition 2, 3, but compound constructions, okay, more complicated. You know, they don't have much. You see, they don't have much examples. They should have a lot more examples. But I think they focus on their string patterns, string expression, which is their alternative syntax for regular expression, which is more readable. Anyway, so we didn't. So anyway, so I think that's a documentation problem. So now, can we go back to our problem by trying to fix this? So far, is there everything clear? No, because we still don't understand why this works. True. For example, let's make it simpler. A9, A98, okay, A97. Let's say 1, 2, 3. Run it, it'll return true. Yeah, but why is that? Because the string match requires matching the entire expression. So the \\d plus matches 1. Oh, I got it. So it matches 1, then the rest matches 2, 3. So is it repeated twice? Yes, because 1 is a sequence of digits, 1 or more. 2, 3 is a sequence of digit 1 or more. So they got repeated, even though the exact numbers are different, but they are indeed a sequence of digit repeated. So that returns true. Now I understand that. Okay, now that also explains the Python case. you see it matches 1. Let me write down 1 as first sequence of digits. It matches 2, 3 as second sequence digits. Therefore, the result is true because the pattern backslash, fuck the backslash, the backslash d plus is repeated twice. Okay, so that is why this match. Okay, now we know why. Okay, now go back to Wolfram language. Now now we know why. We can rework this to be what we want. Okay, so what this needs to be, let's see if this can be done by regular expression at all. First of all, you don't need the $sign, and because you don't need the $sign because in Wolfram language the StringMatchQ requires to match the whole thing. Okay, so but you need to refer to this. Okay, so instead of that, let me show you how. Okay, so let's say let's just say A8. Okay, so first of all you have that, then you don't need the $sign. Okay, then you just say backslash 1. That refers to the previous capture. So this should return true. Okay, now to test the contrary, let's say 1, 2, this will return false. Fantastic and beautiful. We are on track. Now let's test more. Now let's say AA99. Wait, that will return false. Okay, so now, but let's try A8, A8. It'll also be false. That's right. Now let's try A9. That will be true. Beautiful. Beautiful. So now we made one progress milestone. Gerard, hi from the other side of the earth. Hello. Hope you enjoy today's talk show. So we made a progress. This can indeed be done by regular expression. Okay. And what about, so let's try this number. So this number, so copy, cut, run it, should be true. Okay, now but if you add a little more number there, it'll be false. Perfect. Okay, so this can be done by regular expression. What about alternative ways? So to solve this problem, you split the string, then you got a string that is a syntax specifying a range. Then you need to split them again, so you got two numbers. then you need to turn the string into a number, then generate all the numbers in between. That's the easiest way to get all the numbers, okay? So then you got a list of numbers. Then for each number, you need to turn them back into a string. Then you do this regular expression match. Okay, if it matches, push it to a new result list, something like that. Okay. Okay, so we can now we know what's the problem. Okay, now now let's have a break. I mean, let's clean up our stuff. Let's clean up our stuff, all this testing code. So yeah, let me just clean up. So the question is, let me comment out. We don't need the anchor because string match requires what? The whole the pattern to match entire string. Okay, so for example, ABC, then let's just say let's say ABC false, right? So you need to have ABC, then that's true. And you don't need to say begin and end. That will be also true. If you put it there, it doesn't matter, okay? So that's one issue. Now, the second issue is this return, there's something odd. Let me show. So here is an example. This example return true because the pattern is one or more digit, but not specific. So the first match is 1. The second match is 2, 3. Therefore, the non-specific digit sequence are repeated twice. Okay, you see, that's true. So that solves the puzzle. We puzzled over it for like 20 minutes, all these examples. So now we can remove it. Okay, so that should clarify syntax color showing browser. Today's talk show notes. There's a Python example, Wolfram language example, explaining the string match tricky parts. Now back to our actual code. So now we want to do this. So we know regular expression should work. Now let's double check on the say hi, okay? Say hi here, you guys. Say hi, say hello. If you code Wolfram language before, say hi. If you came from Python or whatever, say hi. Or if you are a student, say you are a student, something. Or if you are a mathematician, say something. So we back to this Advance of Code 2025 day 2, problem 1. So it asking range of numbers if they repeat. And also if the digit begin with 0, it doesn't count, okay? So there's this digit begin 0, but is it actually possible to have a digit begin with 0? Let's see the input. Search for 0. No, why would it let's see, comma, replace comma by comma, new line, okay? Do it. So is there any actual number sequence that begins with 0? No. We just look at the input. So the restriction, you see this particular restriction telling you that none of the numbers have leading zeros is just to prevent you from generating this sequence by using strings. So you might get a 0 in front of it. Just to make sure, that's why. So, that's what it is. The actual, so in fact, this needs not be part of the specification, because it already says this number, these are sequence range, number range. So by common sense, number range does not begin with 0. It's not strings. It's a number range. It's not string range. Okay. So that is actually redundant. So that's a criticism of this advance of code. Sometimes it overspecifies, sometimes it underspecifies. So anyway, because none of it numbers actually begin with 0. Okay, so we got it. So okay, close it. So what we do now, so we start to code it. Okay, let's just start to code it. So split input, then for each, okay, new input list, okay, new input list equals to map. So for each of those split input, you got a number like that, okay? So map a function, so you just say function. Function, that's a string, so you need to split string again. Okay, you need to split string, this time by a dash. So you got 2 numbers, okay? So split string, x is the input, you got 2 numbers. Then you say range, okay? So you just say range. That will turn it into a sequence of range. Now, that's a shortcut. What this actually do is I can show you, okay? So let's say, 95 to 115. So that's one of the number you can see at the top. So if you run this, it's gonna be a list of 95 to 115. Oh wait, this should be a comma. Okay, run it. You see? So what is that add? That is shortcut for apply. So when you have apply a function, then x can be written as okay. So this add is just the shortcut for that. So when you want to write range, so this is just shortcut for that. Okay. So let's not use the shortcut because the shortcut people get confused. So I mean, so let's here range, but it's much simpler, you see. But if we don't use the shortcut, then it's gonna be apply the range function to this. Okay, so these two lines are exactly equivalent. Okay, so now let's make this part into a little example here, tutorial, so that people can understand. So in fact, if you run this, it's gonna return that. Okay, they are exactly the same thing. It's a shortcut. Oh wait. Oh well, yeah. So if you apply f to x, and if those are symbolic, you just get yeah. Well, I'm not gonna explain. Well, because it applied to the argument, it doesn't apply to the list. So do you see what I'm saying? Okay, nobody's commenting. Okay, so let's just put here so people can see that example. Let's say 3 to 11. Okay. Simple example. And what did I want to explain here? Well, yeah, okay, so wait, so so actually this explanation is not so good because the reason it returns that is actually because range can also take a list. No. Well, okay, let me so basically when you have apply f then x, the shortcut is actually f at x. Right? No. Right, so apply applies to the argument, not the list. Right, so if you have that, then you get fx. That's right. So apply this, the second argument, and the rest should be are actually the function's arguments. Anyway, let's not be stuck over this. Okay, the detail about that thing we can find. Do we actually have a apply tutorial? Apply, yeah. So there. Okay. Oh yeah. So the shortcut is add. Okay, that's right. So you can read about that there. Okay, so but now let me go back to what we want to do. So what is this? Yeah, talk show like keys. Let's add the link there. Then go back to our code. So let's just write the without the shortcut, so it's easier to understand. Okay, so we map a function to this splitted input and apply a range. So we got a nested list, and the result is let's actually. So let me show you the result there. Okay, so you got that. Then if we do this, let's make it. It can be one line. Actually, one line is not so good. So if we do this, you got list of okay, so you got oh, you forgot to turn them. You need to turn string into number, then you can apply range. Okay, so here you need a function. Okay, function. So let's name this y. Okay, then don't get confused. Function range range at, wait, so string split, you want to turn them into string split, you got two numbers, you want to turn them into list and two expression. Split string, by that split string, so you got a list of two strings. Okay, so here that's what we want. Yeah, so if we evaluate it there, so you can see this is the output, and let's format it better. Okay, so okay, so you can see that's output. Now this error, let's delete them. Okay, and also we can run this in Wolfram language. Select all, paste. In fact, we don't want the comments. Okay, so delete. So here's a code. Shift enter. So you got list of ranges. Okay, then what's next? So did we save the input? Yes, new input list of ranges, list of numbers. So what is the problem? So you want to find in the invalid IDs. Okay, so you can go through the invalid IDs, adding up all the invalid IDs. Okay, so you can apply cases. Those are numbers, you want to turn them back to string. Okay, so here is cases. Okay, let me show you. Cases return all. Cases is like filter. It returns all elements in a list that satisfies some pattern. Okay, we don't want cases. You want select. Okay, select use a function. Cases use a pattern. So select is like a filter. Okay, so data is a list, criteria is a function. So when you do this, you apply this to every number, each and every number. Okay, so let's do that. So what we can do, so let me show you an example. So for example, here, let's pick a list. Okay, so select, here's that your data. Then we want to use our regular expression function. That, so criteria needs to be a function. So function, and the function, basically the body will do the string. So but first of all, it needs to turn this number into a string, from number to string. So do we have toString? Yes. Okay, toString x. So here's a function of one variable x, then you turn it into a string, then you do string match with this regular expression. Now if it returns true, then that item is selected. Okay, so we can run this. Let's run this. It'll filter it out. So there is one result. Okay, so that's your function. Now you just want to apply this select to this entire new input list. Okay, so map, the all-powerful map, the map we want to map to new input list, and by a function, the first argument is a function. The function will be something like that. Okay, and the third argument is the level. So we want to apply to the nested list. So that's in level 2. Okay, now if you don't know what that is, if you go to my Wolfram language tutorial, apply, then the list section, basics, comment, print, string, number, boolean, list. So introduction to list, the most powerful data structure in Wolfram language, the most important. Then there's a section on level that tells you the idea about level nested. When you have a nested list, each element has a depth. So a specific level of a data list means specific set of the elements. You see, so this is level 1, this is level 2, this is level 3. Now in our case, we got this bunch of nested list. So we want to map each element. So those are level 2. So this is kind of novel idea. You don't see this in Python or JavaScript because their map only map to level 1. That's it. But in Wolfram language, you can map to like specific elements at specific depth of a nested expression. Okay, so that's what we are doing here. So we map this function to this new input list, which is this, and at level 2. Okay, and then what the function needs to be something like that. Okay, so we need to say here it gets complex. Okay, so delete that. So the function will be so the input will be x number. Okay, let's just name it that. So select, so in fact we don't select, we let's see, we can just, okay, let's regroup. In fact, select can be placed on a level. Let's see, select, let's see, select, does it take a level? No, it just work on flat list. Okay, so let's not do this. Okay, let's just level 1, use a normal map. Okay, so this will be number list. Okay, so that's your input, the function's argument parameter. So that's number list. Then okay, then you select, then inside that you have a function string match to string x regular expression. Okay, that okay, that's it. Okay, let's try to run this in Wolfram language. Okay, select all, paste. That's our code. Go down, shift enter. Fantastic. So the result is just sum of these. Okay, total, paste. Okay, list of unequal length. Okay, so then we can just say flatten the whole thing. Okay, so 1227775554. No, exactly correct. Okay, nobody comments it. Okay, 1227775554. Fantastic. Okay, so let's just then that's the result. So let's just say then total at flatten at map. Okay, that's our solution. So is it beautiful? Okay, that's it. So that's the code. So let's, if you select all, paste, shift enter, then you got that number, which is the solution. Now, if your input is your user input, can we try that? Yes. Okay, let's try that. So put it back, syntax correct, showing browser. So we got today's code. Wait, did we? No, we didn't. Oh God. So open it, put it back, correct, showing browser. Yeah, so that's today's code. And these, let's move these out so that that's just testing, right? Yeah, let's clean up. We don't need those. Okay, so go down. Let's clean up this. We already solved that puzzle. Okay, so here's the code. So now put it back, cut, paste, make a copy, and search for input. Copy that, close it. Syntax correct. And then just let's. So now the input, the new input. Okay, select all, paste. There it is. Let's remove the examples. So output, so that you just see the input. Let's remove all the sample code. Okay, that's the solution. Copy all, select all, paste, shift enter. Oh, it's taking a while, so shit. Anyway, here is the result. Can we run this in here? Yes, run it. Okay, huge result. Okay, now all we have to do is just put a semicolon to suppress the output. Run it again. So here is the answer. Copy it, go back to advanced of code, answer, paste, submit. That's the right answer. You are 1 gold star closer to decorating the North Pole. Congratulations. So fantastic, we done. Is there anyone congratulating me? Fantastic, okay. So now let's put the code back. Okay, and now let's just do some cleanup so that this becomes a tutorial for those learning Wolfram language. Yeah, so here is a step-by-step output so you can see what is going on. And this select example, let's move it out so you can kind of see. Okay, so So let's make it, so this is clear. Okay, so thank you guys for watching. Hope you like it. We did, how long did we take? 90 minutes, something like that. The solution is elegant. We can make this, we can like compress this into one single line. Like lots of these are redundant, and there are alternative solutions, but we are using regular expression. We can also use string expression, which is Wolfram Language's own syntax for string pattern. And then alternative solution is not to use any string pattern. You deal with number directly. In that case, you take apart the digits. You do digit manipulation. Okay, so let me write it out. Okay, so summary. We solved the problem by using regular expression. We can also use Wolfram string expression, which is basically alternative syntax. Wait, don't I have like syntax for regular expression? Okay, or we can solve it. Another way to solve it is by taking the digits apart. Okay, and Wolfram language has lots of functions that takes a number and returns the list of its digits and do all kind of manipulation on the number on the digits. So anyway, that's it. Thank you guys for watching. So if you enjoyed my show, my programming stuff, go to xali.info, http no s, and go to the bottom, pay me, okay, Patreon, Amazon gift card, PayPal, okay. Thank you guys for watching. Bye guys. We shut down in 1 minute.